Sometimes we take off some time from work to go skiing. Sometimes we just stay home to take pictures of the dog. Sometimes all I can think about is ice cream. And sometimes all I need to do is stay home and watch rebroadcasts of the Eagles winning the Super Bowl. That feels good. So today what we're going to do is draw speech spectra using Praat and R. So you can create good publication quality images such as this or this. Let's think about how to do this. You might remember from a previous video in this series that we can use a script to draw spectra comparing sounds in Praat, and they show up in the image window ranging from blue to red, and this is pretty good for interactive comparison, but I wouldn't necessarily drop this into a paper. So what we need to do is take that image, turn it into something real nice. So what we need to do is in Praat, not just export the image, but export a table of all the values that we can read in using R and then plot with whatever aesthetics that we like. So let's think about how to do this. So here we are with Praat, and just as a quick reminder of how we used that old script, it would just ask us for however many sounds we wanted to draw. I'd select all of them, and it would show up in the picture window like this. So what we want are the values that led to this image. So the way to do this manually would be to select each sound, go to the spectrum, create it, press OK, and then tabulate, and you'd want to include the frequency and the power density. I'm going to hit OK, and now I have a table with these values. So I can export this table and save it on its own, but if I'm comparing lots of sounds, what I want to do is perhaps combine all of their spectrum values in a single table. So that's what we're going to do now. In this new script, which will be linked in the description of this video, what it's going to do looks very similar to the old script. However many sounds you want to use, select them all, press continue, and now it has produced a table for every single one of them. But in this case, what I want to do is combine them into a single table, so I'm going to click yes. Now I have one table, and it's formatted these column names so it just has the sound number it came from, or in this case the name of the sound, the frequency, and the intensity, with column names that will be pretty easy to write once we convert this over to using R. So what you want to do with this table is save it, for example, as a comma-separated value. In this case, I'm going to save it in this folder called My Spectrum Table. .spectrum. You can really call it whatever you want. The file name is just a bunch of text anyway. So I'm going to, while I have this open, copy the file path as I save it. Now when I call up R, I'm going to know where to go. Okay, so here we are in R. I've loaded up two packages, ggplot2 and zoo. You'll see why we're calling up zoo in just a few minutes. So the first thing I need to do is make sure I'm in the right folder. So the one I just copied, all I did in this line of code was make sure that these slashes are going either in the correct direction as forward slashes, or I have two backslashes just to make sure it runs properly. So I'm going to run that line. And the next thing I want to do is actually read in that spectrum that I saved. So what we're going to do is type in spectra will get us read CSV my spectrum table dot spectrum. I'll run that line, and now we can see that we have a data frame with all those values: the name of the sound, the frequency, and the intensity value. And this is a pretty long data frame. It has 8,200 rows because the spectrum was sampled pretty densely. Okay, so let's think about how to plot this. So here we have some lines of code that'll produce a plot for us. Just to walk you through here, the first line of it just sets the name of the object I'm creating. Here's the main function. We're going to use ggplot on this data frame called spectra. Here I'm setting the axes. The x-axis is frequency, the y-axis is intensity, and color is going to map to the name of the sound object in that table, the thing that was declared in that first column. we're going to plot a line for these data, and here we're just going to set the limits of the panel. This line just makes sure that the background is white rather than gray, and this one produces what's called small multiples, or little panels that correspond to each sound. So if I run these lines of code, it's created the plot, but it's not printed yet. So what I need to do is actually run this line here, and now it's going to show up. So we have 8 panels here corresponding to the 8 sounds we measured. We can see that they're all showing up as spectra, and they look like spectra to me. But what I really want is for them all to be on the same panel, and I might also want to smooth out some of those lines. So I'm going to scroll down to my code here. Now we have some code to create a single panel plot, and notice the only thing that's really missing here was that facet wrap line. So now it should all produce on one panel. But you'll notice this is not very easy to read yet. So as opposed to that image that we saw before, where the lines were pretty smooth and very clearly articulated and they were pretty thick and easy to see, this one kind of looks like a mess. And the reason is we're seeing in such detail that we're really providing too much distraction on the image, and what we really want to do is smooth over these lines just to create a simplification. So let's think about how to do that. What we're going to do is use the zoo package, and we're going to run this function called roll mean. So I'm going to take this data frame, put in a new variable called intensity smooth, and what it's going to be is a function of the variable intensity, but it's going to be a rolling mean of 20 values. So if I run that, now I'm going to have a new column to use. So now we have some new lines of code we can run. The only thing that's really changed about this that's important to keep track of is that now the y-axis will map to intensity smooth rather than intensity. So let's see what this line looks like. Now we have something that's a little bit easier to digest. So there are a few more things we can change about this, such as making sure that this color pattern sticks to the color scheme that we want. We can make the lines thicker. I can continue playing with the axes, and I'll leave those decisions up to you. The main thing that we wanted to do today was make sure we can export those values from Praat so that we can call them in using R, and then use the basic plotting functions that we're probably familiar with if this is the programming language you use to make your images. So for those of you who are interested, I'll walk along how I might start to approach that process. So the first thing I want to do is, instead of having this variable called name, which is a string variable, I want an actual number on there. So here I have a line of code that says add a new column to the data frame, spectra, called step, and what it's going to be is a numeric version of a substring of this name. And so because the names are all just step underscore number, I know that the 6th character is what I want. So when I run this, when I evaluate what that step gives me, it's just a bunch of numbers. So it'll be 1 through 8. Now what I can do is take that code, and now instead of mapping the color to name, I'm going to map it to step. Now there'll be a couple things that will be challenging as we produce this plot, and we'll work through them step by step. So let's first see what it produces for us. So when you see an object like this with a lot of vertical lines, what it means is it's trying to connect all the data in a single line, and that's definitely not what we want. So what we forgot to do is declare the group. Color is step, and the group is step. Now it's going to produce a different line for every step. Here we go. Now the colors are gradually changing from blue to black. And another thing I can do is just make these lines a little bit thicker. So this time I'm going to say the size of the line will be 1.8 as opposed to the default 0.7 or 0.8 that ggplot uses. There we go. And so one of the remaining things that's different about this and then that original image that we showed before is that instead of having a legend, we might want to have direct labels on top of these formant peaks right here. So you can play with the legend, you can play with the axes. One thing you'll definitely want to do if you're exporting this plot is make sure that when you export it, it's at a size where the axis text is pretty legible. So for example, if we want to save this, I'm going to type in ggsave, that's the object. The file name is going to be called myspectra, and we'll see how this set of coordinates, this set of dimensions looks. Here's what it gave to us. So you'll see that the axes have to have labels. They're not labeled yet. The legend doesn't have all the different step numbers, and maybe the lines are a little bit too thick, but we're clearly on the right track. So we can continue playing with this. I won't spend the whole video doing this, but some of the things you might want to consider is, for example, an X label that's not just frequency, but frequency in hertz. The Y-axis label is not just going to be intensity underscore smooth, it's going to be intensity in dB. And maybe even though on the preview window this size looks good, when we exported it, it was a little bit thick. So let's reduce this down to 1.3. Save our file again. And then we get something that's working towards something that I would want to put in a paper. So the last tip I want to show you here is converting a color bar into an actual legend. So somewhere in this line of code, what I want to put is a line that says the guides for color is going to be a legend. So let's see what this produces. It's not going to be perfect yet. You'll see that it's going to still choose a subset of those values. It still just wants to give us steps 2, 4, 6, and 8. So what we want to do is introduce breaks. So I'm going to type in scale, color, gradient, breaks equals 1 through 8. Now let's see what it gives us. There we go. We have a legend entry for every value of step. So now let's see what this looks like when we save it. I think it looks pretty good. Well, back to the ice cream for me.